Hey, charat. Bitaw. Hi guys, good day. So welcome to my discussion for today. So I'm so sorry na for the delay of this video. Pero ang importante is I'm doing right now. So yeah. So for today we'll be discussing about general chemistry. I mean just a few introductions and a few topics now from the start. So I know that we've been familiar with general chemistry ever since like late sa tong grade school days. But I do believe in the power of review and I do believe in the power of refreshers. So hopefully no from this kanang lecture na ako, although redundant na kaya mga topics is I hope that you still got a lot of points to remember or points to take note. So let's start. So basically, the topics that we will be covering today will be the units of measurement, scientific method, atoms, elements, and the periodic table. So let's start with measurements. So there are generally two types of measurement. We can have a quantitative measurement, which involves numbers and units, and then the qualitative measurements. Also, there are two types of systems of measurement. We have the English system and the metric system. So basically, English system is commonly used in the United States, while metric system is the most commonly used. It is because first, it is simple and convenient, and yeah, it is less complicated. Now, this metric system is later revised in France and was called as the System International d'Units, which basically is the meaning of the abbreviation SI, or the International System of Units. So that is the most commonly known system that we are using right now. So these SI units have seven base units. So we have the length, the mass, time, temperature, electric current, amount, and the luminous intensity. So we have here presented is the symbol, its unit, and its abbreviation. So yeah. Now, in measuring, guys, we have uh, this thing called uncertainty. So this thing is dili jud siya kalikayan, no? Because few factors of this could be a human error or a device error. So we have been dealing now with this kind of error na actually ato ni siyang i-report sa ato ang final reports this kind of uncertainty in measurements. Now, in dealing uncertainty in measurements, there are actually two um, basic concepts in this. So we have first is the accuracy. So accuracy refers to the agreement of the measurements to the true value. So the nearness of your or the closeness of your measurement to the true value. So we have this thing called the true value. Now to measure your accuracy, we have the percent error. So in computing the percent error, we have this formula. That is the quantity of the true value minus the experimental value all over the true value times 100. And then the true value here is also known as the accepted value, while the experimental value is the actual measurement that you obtained, that you recorded using a measuring device. So the second one is the precision. Now, precision refers to the agreement of your results or data with one another, or the closeness of a set of data with one another. Now, to further understand these two concepts, I have here a diagram from the book of chemistry by Brown. So we have here in the first picture, this is defined as a good accuracy and good precision. So good accuracy because uh, all of them are in the uh, center of the dart, which is represented as the true value or the accepted value when we play darts, right? So we always aim for the bullseye. Now, it is also in good precision because all of the three darts are close to each other. They are all in attached to the center of the dart. That is why they are precise and also they are accurate. Now, the second one is in good precision because the three darts are very close to each other, but they are not accurate because they are far from the true value of this. They are far from the center, that is why they are not accurate. Now, on the last picture, this depicts a poor accuracy and poor precision representation because first they are away from each other, that is why they are in poor precision, and then they're also um, far from the center of the dart, which is the true value. So they are not accurate. Now, to further quantify to understand the accuracy versus precision, we have here a problem. Now, in this problem, Bianca and Luz both measured the mass of a block of wood 3 times. So they recorded the following observation. So we have here the table of the results. Now, the exact mass of the block of wood is 5.36 grams. Now, the question is, who is more precise and who is more accurate? Now, let's tackle first its precision. So, recalling, precision is the closeness of the results to one another. Now, based on their results na, it is obvious that it is Lutz results that are very near to each other. That is why um, Lutz results are the precise one. Now, in knowing the accuracy, we can use the percent error to know the accuracy of results. Now, we have here the solution. So we have Bianca's percent error, which is the true value minus the experimental value all over the true value times 100. So we obtained here 0.180%, the Bianca's percent error, and we have 0.373% for Lutz's percent error. So since this is about percent error, the least percent error means the more accurate result. So that is why it is Bianca's results considered to be the more accurate one. So also scientists have this system called significant figures, which they used in measuring uncertainties of the results that they were able to gather. So that is how the significant figures were used in science. So this also has rules. So let's tackle those rules. Just a quick review lang no, because we've been encountering na many times. So rules in determining significant figures. So the first one is all non-zero digits are significant. So we have an examples here. So it is already self-explanatory na, no? And then the second one is zeros in between non-zeros are significant. So that is why 3.02 here has three significant figures because they are in between non-zero digits. So the third one is zeros at the end of a number are significant if the number contains a decimal point. So the zeros at the end are only significant if they are in decimal point. So we have here this example. That means all of them are significant figures. Now the fourth one is zeros at the beginning of a number are never significant. They merely indicate the position of the decimal point. So like for example here, the 0.002216 only has 4 significant figures because the zeros here at the beginning is not significant. They only indicate the position of the decimal point. yeah. So the last one is, the last one actually supports the third rule. That is, for whole numbers, zeros after non-zero digits are not significant unless a decimal point or a bar on top of the zero is placed to indicate the zero. So basically, if the numbers or the digits are not insignificant, I mean the digits are not in decimal points, and then it contains zeros at the end of it, meaning automatic dili na na siya significant. So for example, if we have here 1000 ml, so due to the fifth rule, 1000 ml only contains one significant figure, which is 1. However, if we translate 1000 ml into 1.000 times 10 to the power of 3 ml, so that means it is already in decimal points. So that accounts the 3 zeros after the decimal point. So just like the example here, so this automatically has 4 significant figures. So that is the power of decimal point, guys. So yeah. So those are the rules in determining significant figures. Also, we have also rules in calculating significant figures. So the first one is in addition or subtraction. So, excuse me. So in addition or subtraction, the result must have the same number of decimal places as the measurement with the fewest decimal places. So automatic example, we have here a 450 ml, which is precise to be in tens place, and then a 27.5 ml, which is in 0.1 place. So automatic no nga 450 ml is not in decimal point, meaning it has 0 decimal place. So the result for that should be in precise in tens place also. So that means 480 ml. That should be the arrangement or the result when adding or subtracting or not, guys, because in multiplying and dividing, the result should contain the same number of significant figures as the measurement with the fewest significant figures. So if in addition or subtraction ang decimal point ang inyoha nga muna yung basihan, in multiplication and division, it is the significant figures. So, for example, we have here 2 significant figures multiplied by 3 significant figures. So, the result should have the measurement with the fewest significant figures. That is why your result should be in 2 significant figures also. So, that is significant figures in calculations. So next is the scientific method. So all of the laws, the theories, the discoveries, and the inventions of the scientists actually are based on this kind of based on a systematic approach to solving problems, which is called the scientific method. So scientific method provides a framework as to how we can arrive at answers to our questions. So I have here a step-by-step representation of the scientific method. So the first step should be collecting information. So in collecting information that is based on your observations, on the different behaviors or natural phenomenon that you wanna raise question with. So the second step is formulate a hypothesis or hypothesis. So hypothesis is a initial explanation or assumption on the behavior or observations that you had in your first step. So that is when you formulate a hypothesis. And then the second one is you test the hypothesis. So that is through experiments, so experimentations. And then after that, you formulate a theory based on the results that you had in your tests or experiments. And then you repeat this in order to come up with the best result on your that matches your hypothesis. So I have here an example on how to in applying the scientific method. So this is just like an elementary-ish um, example. So for example, your first step, like in observation, you have a flashlight that doesn't produce any light. So, sorry. So the possible cause for that, which is your hypothesis now, is that the first one is that maybe the batteries are already worn out, and then you have a second hypothesis that there could be a loose wiring connection between the bulb and the batteries. And so after that, you test your hypothesis. So in testing your first one, you replace the batteries with new ones, and then the second uh, hypothesis, you open the flashlight and then tighten the head and the handle and all of that. And so after that, um, you evaluate your results. And then if you still don't have those results, you repeat your experiments until you come up with a good theory. So that is what the scientific method is all about. Yes. So this is a part one of our lecture, guys. Let's proceed to the part two, which is all about matter. Very familiar, no? Yes, we've been dealing this since we were 10. So yep, welcome back guys to matter. So quick throwback. So I have here a definition of chemistry that I could like connect no to my topics and all. So chemistry is the study of matter, its properties and the changes of that matter undergoes. So this matter basically defined as the physical material of the universe. So basically it is anything that has mass and occupies space. Now to easily identify matter, it has this thing called its properties. So the property of matter could be classified into physical and chemical properties. So basically, physical properties of matter is a characteristic that can only be observed without altering the identity of the material. Now, chemical property, on the other hand, can only be observed when the matter or the material undergoes chemical change. Now, properties of matter can also be classified into intensive and extensive. So basically, intensive properties are inherent characteristics of a material, and basically it is defined as a characteristics of matter that doesn't change as the size or the amount of matter changes. So it is independent to the size or amount of the matter. So those are intensive properties. Now, extensive properties, on the other hand, are characteristics of matter that changes as the amount of matter also change. So they are dependent to the amount of matter. So example of intensive property is the melting point, the boiling point, and then in extensive property we have the density. So yeah. So next is the classification of matter. So we are all familiar in this view, but for the sake of review, I will be refreshing it to you guys. So matter is divided into like two concepts. So it is either um, with definite composition and with variable composition. So a matter with definite composition cannot be separated by physical means are called pure substances. Now, a matter with variable composition, that means it is composed of a lot of stuffs and can be separated by physical means, are called mixture. Now, in pure substances, we have uh, pure substances that contain only one atom, and then we have composed of two or more atoms, I mean elements. So if it is in its simplest form, it is called an element. So elements can be a metal, metalloid, or non-metal. And then if a pure substances is if a pure substance is composed of two or more elements, it is now called a compound. Now, a compound could be an acid, a base, or a salt. So that's for this part of matter. Now, the other part is when a matter is in various compositions. So they are already called mixture. So mixture, when uh, distributed uniformly, is called homogeneous. So example of that is a solution. Now, if it is a non-uniform distribution, it is called heterogeneous. So it could be a colloid, a coarse mixture, or a suspension. So yes, that is our quick review on matter. Now let's proceed to atoms. So starting with the atomic theory of matter. So we have here John Dalton, who is considered as the father of atomic theory. So before him, there are also a lot of scientists, that were able to come up with um, investigations or discoveries or studies, but weren't really able to come up with the a theory that lasts. So it was John Dalton who was able to present a theory that actually began the this theory began the marked the beginning of a modern era of chemistry. So it was his theory, which is called the Dalton's atomic theory. So it has four postulates. So the first one is the first postulate states that atom cannot be torn apart. And then the second one shows that each element has its own inherent characteristics that will never be the same with the other, uh, that will never be the same or true with the other elements. And now the third postulate actually supports the law of definite proportions and gave rise to the law of multiple proportions, which we will be discussing on the next slide. And the fourth one also supports the law of conservation of mass. So that is the Dalton's atomic theory, guys. So the Dalton's atomic theory and other laws were able to scientists, were able to establish three fundamental laws, and these are the first one is the law of conservation of mass. So this is very familiar not to us, which basically states that in a chemical reaction, the total mass of reactant is always equal to the total mass of products. And then in the second one, I will just give you an example. So for example, we have a water. So however you obtain or however you discuss now. So however you obtain or however you prepare water, water will always have the composition of having 88.9% of oxygen and then 11.1% of hydrogen. So that will always be the definite proportion of water. So it will not change no matter the amount of water, it will always have that proportion. So that is this second law is all about. Now the third law is the law of multiple proportion. So this states that if two elements like for example, carbon and oxygen combine to form more than one compound, the masses of oxygen that can combine with a given mass of carbon are in the ratio of small whole numbers. So we have, like for example, carbon and oxygen, so they can form carbon monoxide and carbon dioxide, so CO and CO2. So the ratio of carbon to oxygen in carbon monoxide is 1:1, and then the ratio of carbon to oxygen in CO2 is 1:2. So they can combine in a given mass and are in the ratio of small whole numbers. So small whole numbers are na in hanga ratio. So that is what this third law is all about. Now, atoms have this thing called the subatomic particles. So, sorry for that. So, we all know that these are electrons, protons, and neutrons. But now, let us first, sorry for that. But now, let us like have a little throwback now on how these subatomic particles were discovered. So, electrons are were discovered or introduced by J.J. Thomson or Joseph J. Thomson in the year 1897 through the use of cathode ray tube. So, ako ba i-explain? I think you're already familiar now with this experiment, the cathode ray tube. Yep, you are. So the next one is the protons. So protons are discovered by Ernest Rutherford from the concept introduced by Eugene Goldstein. So actually, guys, Ernest Rutherford is a student of J.J. Thomson. Yep. So these protons were discovered through the experiment of alpha particles bombardment into thin gold metal foil. So that is how protons were discovered. And then the neutrons were discovered by James Chadwick in the year 1932. So this he discovered neutrons through beryllium through the use of alpha particles, also alpha particles bombardment into into beryllium particles. Yeah. So that is how neutrons were discovered. So yep, I hope you familiarize them. So we have also here in the table presents the characteristics of the particles, the subatomic particles. We have here their mass in grams and then their charge in coulomb. So moving on, we have here isotopes. So the number of protons in an atom of any particular element is called the atomic number. And then if two elements of two or more identical atoms have the same atomic number but different in mass numbers, they are called the isotopes. Now they only differ in mass numbers because of the presence of the neutrons. So that means that the mass number is defined as the sum of number of protons and neutrons. So since we already know that atoms are electrically neutral because they contain electrons and protons in the same number. So that means that the number of protons in an atom is equivalent to the number of electrons, making them electrically neutral. So that is it. So we have here the format of how the symbol of element is usually written. So we have a superscript, which is the mass number, and then a subscript, which is the atomic number. So since all elements of the same all atoms of the same element are in the same number of protons, usually the subscript atomic number is usually removed na in writing the symbol of element. So let's proceed to elements. So, there we will now discuss on how the periodic table was um, came up, how it came up, so how it was discovered, and then the process on discovering the periodic table. So the first one who attempted was Johann Wolfgang Doberener. He is a German chemist who discovered that some elements could be arranged in triads. So that is why his proposal is the Doberener's triad. So he arranged the elements in triads. So that is the first attempt now. And then the second one was John Newlands, who was a English chemist who related chemistry to music. So he noticed that when elements were arranged in increasing atomic masses, the physical and chemical properties repeated every after 8 interval. That is why he called this arrangement as the law of octaves. But still, it wasn't able to build a periodic table. And then the next one is Dmitry Mendeleev, which is a Russian chemist, together with Lothar Meyer, a German chemist, arranged the element also in increasing atomic masses. So he was the first one who presented a periodic table of elements, but still didn't pass. So the last one is Henry G. Moseley. So he was an English chemist who introduced the concept of atomic numbers. So since Dmitry Mendeleev is arranged lang through increasing atomic masses, but it was Henry who discovered atomic numbers, the concept of atomic numbers, and then suggested that it is better to arrange the periodic table in increasing atomic number. So even though Dmitry Mendeleev was the one who presented the first periodic table of elements, it was Henry Moseley who formulated the present modern periodic law, or the law of periodicity. So that is what the basis of our present periodic table was inspired from. Inspired from. So yep, that is the history of our periodic table. So let's view now the periodic table, and let's review the basic notable notes properties of our periodic table. So we have here the periods, or the horizontal rows, and then the groups, which are the vertical columns. So these vertical columns, they are arranged vertically because they also contain the similar properties. So the elements in groups contains similar are like they contain the same properties now. So we have here the 1A, 2A, 3A, 4A, and then the step-like line here divides metal from non-metals. So if you can observe this from your periodic table, they actually are there to divide metals from non-metals. So yeah, that is the periodic table of elements. Now let us further discuss them. So we have here the alkali metals, which are the group 1A. So they are considered to be the most active metals. So as what you can observe, they easily form hydroxides with water, and then are lustrous, and they're very soft that they can be cut with a knife. So these are the 1A. And then the next one is the alkaline earth metals, which are in group 2A. So they are generally gray in color, moderately hard, and with relatively high melting point. So next is the halogens in group 7A. They are the most reactive nonmetals. So the most active metals are in 1A, and then the most reactive nonmetals are the 7A. So they are called the salt formers. And then the noble gases, the famous noble gases. So they are known as the inert gases because they are generally unreactive, and they are also found in nature as free elements. Next are the transition elements. So these are the B groups. So they are hard and of high melting points, and they form many colored compounds that make them useful in the production of pigments. And then the last one is the lanthanide and actinide series. So they are in the bottom part of the periodic table. So they are also known as the inner transition metals, and also known as the rare earth metals. So these are the um, commonly known or commonly known groups in the periodic table. So that is it, guys, for my review or refresher. Now, I'm so sorry for that very short lang, but I really hope no nga I did give you some insights. Although feel na ako nakabaw ng mga tanan, pero I really tried my best to um to I really tried my best to understand the next topics, no, but I gave up. Sorry guys, nag-give up ko kay wala jud ko na dili ko confident ato to discuss. That is why na-cut akong topic here. But I will still proceed to the next level, guys. So here are the references that I based this topic from. So we have here chemistry from Brown, and then my third year high school chemistry book. So thank you guys for listening and watching and listening. I hope you learned something. More hugs. Bye.